Sorry, I can't be in class with you. You're going to have to watch the video during class. Lesson 2-3 is about slope. The slope of the line is really just the steepness of a line. So if you think about slope, we're measuring how steep the line is. The bigger the slope, the steeper the line, and the smaller the slope, the more flat the line is going to be. Slope also can be described as rate of change, and what we mean is the change in the y values over the change in the x values. When you're looking at the graph of a line, it's an easy way to describe slope too, to say the rise over run. Rise meaning what's the vertical change, and run meaning what's the horizontal change. Here's the formula that we can use to find the slope if you're given two ordered pairs. Slope is always denoted with the letter m, and if you look at the formula, all we're doing is taking the change in the y values over the change in the x values. It doesn't matter what order you subtract these in, as long as you go in the same order on the top and the bottom for x and y. Last thing about slope here is slope has some different possibilities. Obviously, a positive slope is increasing from left to right. A negative slope is decreasing from left to right. But you can also have a slope of 0, meaning there's no slant to the line and it's just horizontal. If the line is vertical, that means that the slope is undefined. So let's try finding the slope of the line that passes through -1, 4 and 1, -2, and then we'll graph the line. So here's the formula in the box. M represents the slope. It equals the change in the y values. The y values are the second numbers in the ordered pairs, so you take -2 minus 4, and you get -6. And then in the denominator, you're going to subtract the x values, the first numbers, 1 minus -1. And the double negative here is really like adding, so we get 2. Now the last thing you do is simplify your fraction. -6 over 2 is really just -3. So the slope of this line is -3. When we go to the graph, here's the ordered pair -1, 4, and here's 1, -2. You can see that the slope is decreasing because it's negative. It's -3. And I want to show you how you can count the rise over the run. Remember, we got -6 over 2. If you count from the left point to the right point and make yourself a right triangle, we're counting down 1, 2, 3, 4, 5, 6. That means -6 over 1, 2, +2. And so you can count the rise over the run. We've got -6 over 2, and that's another easy way to figure out that the slope is -3. In this one, we want to graph the line that passes through the point -1, 4, and it's got a slope of 2/3. So I already have the graph made. What you want to do is start by graphing the point, -1, 4, and then from this point, put your pencil on it. You're going to graph the slope 2/3, counting the rise over run, up 2 over 3, and put your next point. If you wanted to go backwards, you could go down 2 to the left 3, because -2 over -3 is the same as +2/3. And you can tell that we're still on the line. So either up 2 to the right 3, or backwards down 2 to the left 3. One thing I want to mention about graphing slopes and rise over run is that you're going backwards from ordered pairs. When you graph ordered pairs, you're going to move left or right first and up or down second. But when you're counting the slope, it's the rise first, up or down first, and then to the right or the left. It's backwards. Okay, and then connect the points that we've got our line. Example 3, in 1999, 45,616 students applied for admission to UCLA. In 2004, 56,878 students applied. Find the rate of change in the number of students applying for admission from 1999 to 2004. Well, this is clearly an increase in the students that have applied. What you can do is think of the info as ordered pairs. The X values are the years, and the Y values are the number of students applying. So the first point was 1999, 45,616. The next point is 2004, 56,878. Now to find the rate of change, you just subtract the Y values in the numerator again, the X values in the denominator, and we get 26,211 over 5, which tells you this is the rate of change in those 5 years, but you could also divide that out and get 5,242.2 students per year has been the rate of change. All right, the last concept is parallel versus perpendicular lines. Parallel lines are lines that do not ever intersect. They do not cross. And so if I draw you some parallel lines here, there's one, there's the other, it's easy to see that they have the same slope because they have the same slant to them. So one thing to remember is that parallel lines have the same exact slope. Perpendicular lines are lines that cross at 90-degree angles. So there's perpendicular lines. I'll draw in my 90-degree angle. What's important about these slopes is that they're opposite, meaning one is positive, one is negative, and they're also reciprocals. For example, if the first slope is 2/3, the other slope has to be negative 3/2. So the perpendicular lines have opposite reciprocal slopes. So in example 4, we want to graph the line through -1, 3 that is parallel to the line with equation x plus 4y equals -4. Well, the first thing you can do is graph the point -1, 3 because you know that the line that we're going to draw has to go through that point. Then we want the line to be parallel to the equation x plus 4y equals -4. So we're going to have to figure out where that line is. And because it's in standard form, the easiest way to get this line is to use x and y intercepts. So to find the x-intercept, you can plug in y equals 0. So the equation looks like this. And 4 times 0 is nothing, so you get x equals -4. Okay, so this line has an x-intercept of -4, and let's find the y-intercept. To find the y-intercept, you go back to the original equation and plug in 0 for x. So 0 plus 4y equals -4. Divide both sides by 4, and the y-intercept is -1. So the x value is 0, y is -1. That means down here. Okay, so here's the original line. And we want our line to go through -1, 3 and be parallel to this one. You're not just going to sloppily sketch this in. You need to figure out the slope of this line. So let's count the rise over run. From this point, always start with the leftmost point. We're going down 1 and then over 1, 2, 3, 4. That means the slope of this line is -1/4. Negative because I counted down. -1 over +4. So to get a parallel line, I'm going to start at my point -1, 3 and count the same exact slope. Down 1 over 4. And I can connect these points and we have parallel lines. Let's try one more example. This time we're going to graph a line through -3, 1, this point right here. And we want our line to be perpendicular this time to 2x plus 5y equals 10. So we first want to figure out where the original line is. Let's find the x and y intercepts. The x-intercept, if we drop the y term, you're solving 2x equals 10, and the x-intercept is at 5. So on my graph, my x-intercept for the first line is at 5. The y-intercept, the easy way to get the y-intercept is to drop the x term, because remember we're just plugging in 0, so that wipes out, and you're going to solve 5y equals 10. That means the y-intercept is at 2. 5 times 2 is 10. Positive 2 on the y-axis. Okay, so here's the first line. I want my line to go through -3, 1 and perpendicular to this one. So it's going to go in the opposite direction here, up in this area. First thing I need to do though, before I can draw the line, is I need to figure out the slope here. So I'm going to count from the left point to the right point, my rise over run. I'm going down 2 over 5. That means the slope of this line is negative 2 over 5. Count from one point to the next, down 2 over 5. Now, perpendicular lines have opposite reciprocal slopes. So from this point here, if I'm going to graph my perpendicular line, I need to count positive 5 over 2. Or I can go in the backwards direction, down 5 to the left 2. And here's my line. Okay, perpendicular lines, they're opposite. One's negative, one's positive, and they're also reciprocal. So my line's kind of sloppy here, so maybe it doesn't seem like it, but these are in fact perpendicular, and this angle should be a right angle. That's it. We just made parallel and perpendicular lines. Now you're going to work on an assignment in class practicing. Good luck.